So, what are we talking about today? We're talking about the system impact, of course, and how to use the impact design and detailing module in AutoCAD. And to those of you who haven't met me or don't know me, my name is Nikolaj Stephansen, and I'm the team manager for impact in the Danish StruSoft, so StruSoft DK. To continue with what the webinar will be about today, I've just done a rough agenda, which is the same agenda that you saw when signing on to the webinar. And these bullet points won't be in order, so it means that we'll be looking at everything almost at the same time, going back and forth. But that's the important thing of this webinar, is that we're looking at the workflow, so a realistic workflow of how you might work. And we're looking at designing and detailing elements in IMPACT AutoCAD, and we'll get an overview of the custom materials, joints, and recesses in these elements, how we generate and when we generate shop drawings, or production make sheets as they're also called. And I'll give you a very brief introduction to rough planning. One of the reasons why we're doing the introduction to rough planning is also because in 2 months' time, we have another webinar. This webinar then is about fine planning. So ending at the rough planning part here, we'll start with fine planning in a couple of months with the same project actually of where we got to today. And the duration today is approximately 1 hour, plus minus a couple of minutes. So let's just jump straight into the software. So let me close down my slides here and actually open up this project manager tool. Of course, the project manager here is where I manage the whole project, drawings, revisions, elements, and everything will pop up in 3D here as well. So this is also what we'll use for the detail planning on the next webinar, of course. But right now, you can see I'm in the model view. Everything is empty. This means that I haven't got any elements yet. So I'll be jumping on to a floor plan. Here we go, and what is already on this floor plan is an external reference. So this might be your architect, it might be your engineer or whatever customer you have who did the design of the building. I did a little bit design on this just to help me today remember what it is we're looking at. So getting this plan, we're looking at mostly at the plan today, designing through using the plan drawing. So I just want to start straight out drawing this now. So, of course, I go up to walls here. I want to draw a wall. This should be a sandwich wall. And then I pick a starting point. The starting point here isn't that important. The important thing is that the way I want to orient or turn my elements. So I draw all the way around the house, just like an architect would draw his walls. So I'm waiting to split the elements until I get a little further, because the first thing I want is actually to get the walls up there. And this is important for the impact walls, of course, because these walls update lifters and bracing center of gravities by themselves. So as you might notice now, I'm doing a lot of zooming in and out. The reason why I'm doing this is so I'm completely sure that I use the right point here. For this, we can use regular AutoCAD snap settings. And you may have also noticed that I don't really draw the walls in their full lengths, but that doesn't matter here because later on I will have the system control the lengths of the walls for me. So the important thing for me now is just that they need to be there. So if I look at an isometric view, you can see that already I have a 3D of the walls, and if we zoom in a little bit, we can see some lifters and bracings already there as well. But of course, we need to split this up into elements. Before splitting up, I want to draw my solid walls. So I'll do the same command as the sandwich walls and draw these up. There we go. Here we go, and I might want to start from up here drawing this one. So today it's very important for me, as this is a webinar about workflow, to show you the whole workflow. So instead of just showing how to draw 1, 2, or 3 panels, I'm showing you how to detail this entire floor, including windows, recesses, and everything. Oh, let's take this wall. This is the one that we are missing. Some of you have maybe also seen this project before. It's because this is actually our beginner's course project that I did a few tweaks in because I have some features about automatic recesses I want to show later. So we only have these solid walls in the left side of the building. But now I have everything, solid walls, sandwich panels, and everything. And we'll now can actually start splitting up the walls. So I'll get my elements instead of just having walls. So I select the wall I want to split. And now again with the zooming, so I'm sure that I'm snapping to the correct places. Here we go. So this is just to make it, as I said before, easier for myself to do it. So when I've split these walls, chosen where to split them, I can decide which type of connection I want, an end cap we call it in your impact. Now this one, 804 we call it, looks like one that's just fine for while loops and ones that looks like the same that's been defined here. So this is what I'll use. So straight away now you'll be able to see that we actually have some lifters and inserts in these elements. If I hover my mouse over it, you can see element type sandwich wall. The mass is a little under 8 tons. And this element is 3.9 meters times 2.8 meters. So let me just finish up splitting this. We have just a couple walls more. Then we actually also finish with splitting up all our elements. There we go, use the same connection. And jumping to the left side here. Splitting this wall also using the same connection. So just to follow along in the process, let's jump to the 3D again. You see now we actually have elements with lifters and bracings, and I just need to split, of course, the solid walls here in the middle as well. And actually, for this one, it doesn't matter where I split it because I'll have the software calculate that for me as well later. And it doesn't really matter that much which type of connection I use actually anyways. So let's just pick one, let's say like this. And it's up here, but later on you'll see that these will correct themselves automatically. But of course, when I split one like this, just like for the sandwich panels, I want to split it in the right place. So let's choose to split it here. And use this one. There we go. So now I'll split all of my walls in the pieces that I'd like. And as you can see, we have all the lifters that we need. So the next part in our workflow is that one of two things. One thing is I can start adding openings, and the other thing is I can start doing the corner connections. But I think before doing the corner connections, we want to add the openings because then the connections will set up for everything. So drawing the openings, and here I'll draw every single opening on the floor as well. I use the draw opening command for the walls. There we go, I like the D2 door. As you can see, I've written down here which ones I have to use just to keep it simpler for me to show you. And then I'll show you the right thing as well. As you can see here, I rotated the door a little bit. Doesn't really matter that much because I'll just update it in a couple seconds. There we go. So just remove this one. Here we go. And that are the doors for the internal walls. And let's then add windows for the external ones. We start with the F14 here. Start adding those. Again, I'm using the lower left corner of the wall to decide where to place these windows. And we place these 4. Let's just check quickly. Do we have any more of these big ones? We don't. So I want to continue. I just hit the enter button twice. And I can then pick a different one. Say, let's use the F1 now. And set, we'll need one here. And we need one here for the F1. We might need more. I don't think we do. No, that's just fine. Let's go to the F3, which is the standard window, which is the one we have the most of. So, of course, right now I'm just repeating the first action I did. So there's not really anything exciting and new happening right now. I'm just adding different windows. And of course, again, I want to add them all so you get a feel of the entire workflow for the whole plan. Because the workflow can often be very different from what you see in a presentation or anything. When you only show one wall, one window, or one slab, one hollow core, or whatever. So that's why it's very important for me to show you like a complete plan, and also that we can get from here to then in approximately 1 hour. Of course, I've set up a little bit of stuff in advance, just so I know what it is I need to use. So there we go. That was all my F3 windows. And we need to add balcony doors. There we go. And those, of course, should be added where we need to go out into the balconies. I think we have one left here. And now the last thing we're missing is the F21 window. There we go. One there. One there. And you might notice as well that I said I start from the lower left corner, but right now I'm actually putting things in the top right corner. But the lower left corner actually means the lower left corner of the element. So you can see my element text here. So that's how I decide what the lower left corner is. So that means it actually reversed in this case. Here we go. So just going quickly into this isometric view. As you can see here, I actually forgot one window here. Of course, we need to remember that one. And F3, we'll just do that. But other than that, we're actually done with the windows. So what I want to do now is I want to add the windows to the sandwich panels and to the panels, regular panels as well. And this will mean that they will recalculate the center of gravity, recalculate the weight of the elements, and recalculate placing of lift and bracing anchors, and all connected to this. So we'll just say need to update everything. And then the system now rolls through every single element, puts on the connections to the sides of the windows to avoid these cold bridges, all these connections we've added, and end caps as we call it in IMPACT. Recalculate center of gravity for each single element, recalculates the position of the bracings, mounting bracings, recalculates the positioning of the lifters. And if you really look closely, you can actually see it moving through the elements. It's somewhere down the right corner right now, moving through recalculating the elements. And there we go, it actually finished with all the sandwich panels. And we'll do the same thing for the solid wall panels here. So now we've worked for approximately 15 minutes, and we actually have a plan here. Sandwich panels, lifters, elements that are split up, calculated center of gravities, and pretty much everything we need here. We want to do some more detailing. Of course, we want to do the corner connections here with wire loops. So when doing the connections, I use the connect command, of course. And in this case, I only have one connection. And this connection is for my specific point here, a while loop connection with a center distance of 600. I can change the center distance, or I can change the start point from top from bottom, for example, or do different setups for, let's say, I want 5 in each, or I want per 400 millimeters, however you like it to be actually. So I press OK here, and now I'm allowed to choose which element should be going to the end of this corner for. So you can see when I press next here, it changes. This is very important doing for each corner, so we're completely sure that our elements are designed the way we like them to be designed. So now again, as previously, it actually recalculates the center of gravity, the lifters again. It's very important to stress out that every single time I change just the smallest thing in the geometry, the system automatically generates, automatically updates, and just keeps everything so that we don't have to think about recalculating all these things all the time. So it just does it naturally. So for this one, of course, when the orientation and the length of these different walls is so important, it is also important for us to do all the connections. So here we have one with a solid wall and 2 sandwich panels. No issue at all either. We just need a solution here we have. And as you can see here, it will then make the solid wall longer and fit the sandwich panels in for the new lengths. Sorry. So there we go, while loops and everything fits beautifully together here, down to the smallest detail, of course. And let's just go through the rest here. Again, the same as before. I'm doing pretty much the same a few times now, but again, as this is the workflow webinar, the workflow of the entire floor is very important. So we have both outside corners and inside corners. And as some of you may have noticed also is when I mark the elements, sometimes I mark the underlying drawing as well. This doesn't really matter. I just mark it as quickly as I can because IMPACT can tell which is an IMPACT element, which is just a regular AutoCAD polyline or AutoCAD drawing or whatever it might be. So the system quickly recognizes everything it needs to. So now we're actually already spent less than 20 minutes total, closing in on very, very detailed walls and sandwich panels, including lifts, bracings, connections, wire loops, how many wire loops for each, and of course the element weight, etc. So here right now I'm doing a T connection on a straight piece of wall. As you can see, this is also completely the same way this is done. The difference between, for those new of you who doesn't know IMPACT right now, the difference between drawing, let's call it drawing, elements in IMPACT and doing it in something like regular AutoCAD is that we don't really draw in IMPACT. We tell the system, I want you to make this connection for me, and the system then does it. So it's pretty much more of a process of questions and answers, if you might say it like this. We're asking the question, can you please do this for us? And it answers back to us. The great thing about that is when it's the computer doing this, it can't really, it can't draw a line wrong. So if we pick the right solution, if we pick the right connection, well, the system will do it right every single time. So, of course, this makes the error margin much, much smaller than else. And also another thing, of course, is also that we haven't looked at shop drawings yet. We will in a short amount of time. That, well, when we actually do the plan drawing here, we don't just do a plan drawing. We actually do a full 3D, full to life scale model of the building. So a production make sheet or a detailed shop drawing is just one click away. But of course, you'll see this just in a few minutes. So let's go here, and of course it's a little bit sitting looking at creating the same connection 10 times, a little bit boring, but again I want to give you the time it takes. So I think we spend around 5 minutes on this. It takes 5 minutes to do all the connection for this entire floor, and that, well, if I could say so myself, is actually pretty good, because we know that they're going to update all of our production make sheets, all of production drawings with bill of materials and with everything. So now we did all the different corner connections. I actually have a few left now that I remember it. As you can see, we have some special ones here. Different T connection. Of course, we can also do these. And then a very important thing here is that I have the possibility to put the wire loop strand down so it doesn't go into my F1 window here. So this is perfect for me. And what we can actually do when doing this is we can have up to 4 walls in any specific angle. You just need to specify the angle in this connection that you do. But for most cases like this, it is 90 degrees. Of course, it could be an angular connection instead. And what IMPACT is doing right now, as you can see, it takes a couple seconds more than when just doing one wall, is because, well, it scans every single piece and every single element. How many wire loops do I need? Which side? How far distance is between them? So in this case, when I do this, update this, recalculate center of gravity for 3 elements, also puts in approximately 10 wire loops for the solid wall, 5 wire loops for each of the sandwich panels here. So there's a lot of work being done and recalculation being done in the database. So that is perfect. And we, of course, we save tons and tons of time not having to do this ourselves. Let's just do this connection down here as well. Here we go. So you can see there are many, many possibilities of doing different connections, simple connections, advanced connections, with wire loops, without wire loops, simple corner connection of 2 solid walls. So there are a lot of different possibilities, and we try to keep the system as flexible as possible. So that means that all of your specific company details, of course, for the ones that do not already own the system, can be added there. And for the ones who already have IMPACT, of course, we are very happy as always to help you modify your company standard to get the most out of it. The important thing here for us is to show you, well, this is my workflow. So it might mean that someone else does it a little bit differently or does it in a different order. But if I'd added the windows after doing the connections, or if I'd given my element marks, if I give my element marks or something like that before, well, that's okay as well. As you can see here now, I actually have 3 connections to choose from. A 3-way corner connection, or this T connection, which is the one that I want to use. There we go. So now the brilliant thing, after spending 5 to 10 minutes doing all connections for the whole plan here, is we'll just go up in 3D. We'll also save the elements actually, so you will be able to see them in full 3D in our project management tool, and in full 3D here inside actually the AutoCAD drawing as well. So let's just finish up here. There we go. So let's just go out and look at it in the isometric view here again. As you can see now, when I zoom in, I have all the wire loops. And you probably notice that, well, this is not in full 3D, and I mentioned full 3D. If I mark the element, set the presentation for it, I can set it to what is called solid, which will then change the element to show me everything that there is. So you can see here now, I can see, it might be a little bit difficult to see, but I can see the installation, the type of lifters used, the bracings, the wire loops in 3D, and of course how you want this to look in 3D is completely up to yourself, because this might not be how it looks in real life, but it can be. That's something for you to decide for yourself, how you want it to look, how detailed you want it to be. But let's set it back to the wireframe here, because this is usually what we do, what we work in. This is the best for the PC to work with, because it's not too heavy for it. And when we're doing the plans, it's also very simple for us to see where the different elements are. So now I want to get it into my project manager. Of course, getting it into the project manager means that people who don't have AutoCAD, people who don't have IMPACT for AutoCAD, they just need to have IMPACT installed, be on the same database as the other guys. They will be able to see the elements in the project manager instead. And we will have them saved to the database, which means we can also create automatic shop drawings. So let's just save these walls here, starting with an element marked wall panel 1001. And now the system again scans everything and gives them numbers. So they're saved now. If I go into the project manager and refresh it, I might even be sitting in a different office now. Well, I can see that, well, that's great. I have my solid wall panels here. Of course, I want to do the same thing with the sandwich walls. I can pick which walls in which order I want to save them, or I can say save everything. If I wanted to save them, give them numbers, and say, well, I'm doing a erection plan later anyways. So let's just have the system save it, and it can decide when. It just has to start with sandwich wall 1001. The reason why I'm giving the name 1001 right now is because this project I have here is not only one floor, it's actually multiple floors. So by one, I'm just naming this on my floor 1, so it's very easy for me to find all the elements. Even if I didn't, of course, it's pretty easy to find them because you have the project manager in full 3D where you can filter the floors as well. So going into the project manager, just refreshing here. Now we can see actually the walls with even the connections here. What we're not seeing are the cast-in materials, and we don't want to see those because it becomes a little bit too much here. This is a project manager's tool. This is not a detailed designer's tool. So this is great, and well, it actually looks somewhat the way that I want it to be designed. And after finishing up the walls and sandwich panels, I want to add some hollow cores, and I want to add some double T-slabs as well. Before doing that, some of you might have noticed that I didn't put wire loops into the straight connections here. And that was on purpose, actually, because what I want to show you is a different way of doing these, which is called cast-in material templates. So I say, well, I pick these 3 walls here and use my 340mm wire loop connection here. It will then scan all edges of all 3 walls and add wire loops according to my specifications. So you can see now it actually added wire loops. And the elements even turned pink or magenta. This magenta color means that something needs to be saved. So I can go and save the elements here. The reason why it doesn't save automatically is that we'd actually like it to keep the connection or the movement on the database to as low level as possible. IMPACT is a huge database that everyone in your company can access. Of course, there is also an option to have it automatically save always, but that option I haven't set on here. I like to work having to save these elements manually, so I have full control of what I'm doing the whole time. So we have the plan here, and of course we can also add these ones to, let's just do that, to the rest of the walls here. We have a connection there as well, and we have a connection here also. So these are the wire loops in between the walls, just making sure these are there. So let's let this scan the elements through here, and as soon as it put wire loops into all these connections in all these walls here, we will start drawing some hollow core panels instead. There we go. And now we have a lot of pig points. Then we can just say, I'd like it to save walls, save all. Type of wall sandwich. And now we can also choose the element marks here. And now you can see that I give a new name for this one. This is because if we have several elements that are the same, we want IMPACT to only create one drawing of these. So let's say we had 5 walls that were the same. We only want one drawing that says 5 pieces. We can of course also print this one drawing in 5 copies that will specify each and every element. This is relevant for walls, but even more relevant, of course, for hollow cores, which we often have a lot of hollow cores that are actually completely identical. So we want to do some hollow cores now, draw some hollow cores. I have some different sections I can choose. I can add company sections, company definitions, all of the ones you use, of course. I'm just using a standard one called 19 here. I like it to automatically add these type of lifters. And then what I do is just pick points where I want it. So here we could use, if we already had a polyline, we could use that. But instead I'm just picking points from where these should be. And again, with the zooming, as you can see here. Here we go. And there we go. Wanted to snap to the correct place here. There we go. Now it asks us for support length. There is a green highlight here. I don't know if you can see it, but this is where the support length will be. Let's say 80 millimeters, 0 to the right. 80 here as well, 0 here, 80, 0. Now we can decide how they're supposed to be oriented and where I want the cut element to be. So let's say the cut element is one from the side here, and this is what shows with the scissors. We press apply here. And now I have all of my hollow cores actually. What I want to do is completely the same as with the wall. I want to save these into the database. So there we go, starting with hollow core 1001. So if we look at the time now, how much time have we spent in the webinar now? So including the introduction and talking about this, we spent around 34 minutes. So we have a floor with fully detailed elements, including hollow cores, in 34 minutes. Of course, I prepared a little bit of stuff for this, but this gives you the idea of the workflow and the time it takes to add different things. So now we have the hollow cores as well here. Of course, there are some recesses. I drew a couple here. I want to add a recess. Simply draw a recess using this draw recess button, selecting, for example, this element here, and then picking where the recess should be. This one, of course, turned pink again. And then this one, I don't want a recess. What I want is to draw a hanger detail because it cuts out the whole element here. So I pick the element to support and then elements to support this element. And then, of course, where do we need the recess? It should be here. And pick a type of hanger. Here is one for 90 millimeter hollow core. And again, for this hollow core, actually, I have some standard end caps. This one, I don't want the standard end cap in the right side. I just want it to be cut. So I just say right edge none here. There we go. And as the same as before, I will save these hollow cores. As you can see right now, all of these have the same number, but they're not the same hollow cores anymore. So I want to save these. And I do not want them to keep their element marks. I want them to use new ones starting at hollow core 5. And then it adds new numbers to those accordingly. Going in, refreshing here, we will see that the detail is actually also done here. So one thing that we can see also now is what this wall is a little bit too high here. And for this wall over here, they're actually not lying on the wall. So we'll just change that. Let's go in here, choose this wall here, adding the height of it to 26 instead of 28, 15, pressing OK. And of course, it's very welcome to save the lifting. And here it even asks me automatically, do you want to save? And for this one, we want to do a cut for the hollow cores. So I'm selecting the wall, specifying a start point for the cut and an end point as well. There we go. And then this cut should be approximately 120. I put the distance before at 80 millimeters. So this will mean that the 80 millimeters plus 40 will probably be just fine. Of course, I want to update the placing of lift and bracing anchors again. And of course, I want to save this element again. There we go. So looking at our project manager now, we have the hollow cores lying just fine here. We have them lying just fine on this panel as well. So that actually means that, well, for my part here, these hollow cores are designed, finished as well. So I promised another thing before we started, and that was to show you a new feature for creating automatic recesses, and I'll use double T slabs for that. So for this part over here, I want to draw some double T slabs. I still use the hollow core because it's a generated shape with some pre-stressed strands in it. And let's say okay to this. So what I do again now is the same as what I did with the hollow cores. Pick a polyline or points. As I don't have a polyline here, I'm just picking points. But these, of course, have a span that's a little bit larger than the hollow cores. I have up to 12 meters here, I think. There we go. There. Here. And we want to end it there and close it up. Again, with the support length of 80 millimeters, it should probably be more here, but let's just keep it like this for the example. Again, the most important thing of this webinar is the workflow. So there we go, placing the cut there, perfect for me. So now we added the double T's. And we can see here there's actually a recess in between two elements. So I want to draw that. Before, when I did a recess, I chose an element. Now I'll say no elements, but it has to be a slab. I want to do a rectangular cutout. And this rectangular cutout should be in this area. So now I have the cutout first by itself here, two elements. I then pick these two elements and add the cutouts, and I'd like to update the lifts, of course. There we go. So now we have the cutouts in these elements as well. So let's save these double T's. And again, the complete same way as we've always done. Now with DT1001 instead. And looking at our project manager here, we actually have those as well. So now this comes to these double T's also being on top of the walls. And I promised that we had a new feature for automatic recess, draw recess from element here. So now I select the elements I want to subtract from. I actually want to subtract from this one also, and this one, and this one. Here we go. The reason I want to subtract from these are, of course, because of this small part having to be cut. And that is great. I then press enter, and then select the elements to do the subtracting. These are the ones. And now I have some different settings I can set, but for me, vertical gap, horizontal gap, 20 millimeters is fine. 30 millimeters to the side, also just fine. So I'll use those. Update the lifters, which is great. Just do that, go ahead. And then, as before, it'll work through these elements and changing them, doing the recess as it goes. So you can see now, yeah, almost all of them actually already the pink color. So there we go, actually finished. Save the walls, save all, sandwich panels. They can keep their element marks, this is just fine. So there we go. And saving these with all these new recesses, of course, is immediately, we'll be able to see it in the project manager here. So let's just take this one. As we can see right now, they don't lie on top of each other anymore. And let's just isolate this one. You can see it's actually done these recesses now. So you might argue that this is not really the best idea to do just on top of a window this big. So of course, there probably needs to be done some design here, but this is perfect. The project manager can see straight away, tell the designer something is wrong here. We will never make this take all the load it has to take. So let's just unhide everything. So now we actually have the floor that I'd like, and these are all the elements that I need for this floor, for my case here. And that's perfect. So this brings us on to automatic shop drawings. We finished the detailing, but I want to do some automatic shop drawings. So to start with, let's say this hollow core here and this double T here. I want IMPACT to generate shop drawings of these two. Of course, we can generate multiple, but just making these two to keep it simple here. And we can actually open them up afterwards. So now it's generating new files for each of them and opening up. Let's open up both at once. So we'll open up the drawing files for these. So there we go. Here, go look at the drawing. So here we have finished with measurements, even the recess, which is a void, the size of it, the placing of it, the section, strand patterns, etc., etc. Weight of the elements, and everything is taken from this model where all parts are shown. This will be very much more clear when I show you the sandwich panel just in a second. And of course the hollow core here as well, which is very similar to the double T one. But just kept as simple as possible, which with as little information as possible, but still every piece of information that you need. Of course, the shop drawings here also are set up for your standards, and if they're not and you're already a customer, have a talk to us, we'll help you get them set up, of course. So we also want to do shop drawings for sandwich panels. So let's take, for example, this one here and do a shop drawing of this sandwich wall layout, which is fine. For the sandwich panels, it's a little bit special in this case because they're much more complicated than the other elements. So usually we actually need more than one drawing for those. As you can see here now when opening it, the parts here, there are a lot more parts than there were in the hollow core and the double T slabs. Looking at two layouts I have here, I have a main layout which shows me all the geometry without reinforcement of the wall, lists of all casting materials, 5 connection loops in one side, 5 connection loop in the other side. DIM here refers to dimension lines, so DIM 6, which is this one, measures out the wire loops as well. And we have 2 lifters, 2 bracings, so everything's there, the weight, the volume, and everything. Look at, for example, this ready for production pieces. What this means is that there are no elements like this that have been set to ready for production. That means that we've actually told no one that we've finished designing them yet. So that's, of course, the way it should be. So no one prints these out and starts casting them. I'll show you in a minute where to set this as well. Jumping over to the reinforcement part here. This is all the standard reinforcement that I've set up for these types of elements. Of course, we can add more reinforcement. What we planned is we have so much to cover today, and almost all the time is already ran. So we'll do another webinar just focused on reinforcement. How do we make reinforcement the easiest way, the simplest way? Again, with the same thing, doing all these NTO lists, doing all our material takeoffs and everything. So that will be in a future webinar, of course. So that was the drawings. One thing more is that you have your project managers. They do not, perhaps they don't have access to AutoCAD, they don't have access for all these things. They don't need access because they only need to go and look at the elements once in a while. So let's take this element here, this element here. What we'll do is, sorry, I'll just refresh to keep it updated at all times. What we do is now we'll just plot some drawings to PDF, which will immediately be accessible for the project managers. So let's say that this is still the designer, still the detailer. He's plotting drawings. So he wants to plot drawings on his setup that is called, in my case, Test 2, which is PDF drawings in A3 size. So I'm pressing plot here. It starts to plot, works in the background. Meanwhile, it's plotting up, opening up. It's doing 2 drawings for this one reinforcement, one general one drawing for this one, which is just a general geometry one. Let's go into this element ID tab we have here. And in here we can see our rough planning. As we can see, there are no plan dates at all here yet. But I want to plan an erection date, and I'm keeping this simple because I want to do erection sequences, I want to do deliveries, I want to do planning of casts and everything in the next webinar. So I'm just keeping this really simple now. I'll finish the plot meanwhile, and I'll set them all to one date because that means that I'll know the latest date that everything has to be finished. I'll do that in a second, but firstly, let us look at the drawings here. So let's say that now we have the hat on of a project manager who doesn't have AutoCAD, but he wants to see the drawings. He actually wants to see both of these element drawings at the same time. He will right click, he will open them in the PDF viewer, which is built in to our project manager tool. So this opens up, and if I just press this button, we can see here, this is our double T, black and white plotted as per the plot settings. And going down, we can see the geometry drawing of the wall, and we can see the reinforcement drawing of the wall. If the project manager then wants to plot this out to a physical plotter, he can then, of course, just do that straight directly from in here. So he doesn't have to contact anyone in the design department, of course. Importantly also, we can also see if this is ready for production or not. So we can see up here, it still says 0. So first thing we'll do here, jumping back to the rough planning, which is of course the last part of our webinar. We'll say that, well, I have an erection date, but let's go in and pick all our sandwich panels. These are the sandwich panels. Those we want to be erected the latest here, let's say March, April, May, June 20th. So let's say that we can erect all these the same day. And let's say that we can even erect the solid walls as well the same day. But for the hollow cores, those will be erected the day after. So this is both the hollow cores and the double T's. And we can, of course, tell the difference right out here in the name that we gave them before. Let's set the planned erection date here as well to now the 21st instead. Apply. So let's look at the building here. For all elements, everyone has planned erection dates. Then we need planned delivery dates. So what I'm doing is I'm picking all elements and I want to set the planning. I want them to be delivered the day before. It might be hours before, but in this case, let's say the day before. So I want to change the date of the planned delivery date using the planned erection date -1. Pressing apply here. That means that these walls are supposed to be delivered the 19th and the hollow core the 20th. Backtracking here, when do they then need to be stored? Well, probably again a day before the delivery or something like that. Or the latest. It might also be 5 days before the delivery, but we can set this how we like it to be. We can then set the planned production date, which will probably set, maybe we need to set this as actually a few days before we want them stored. Maybe, let's say maybe 10 days before. Because what we want to make sure is here that if there's anything wrong with these elements, of course we need time to fix it. So if there are any elements that have broken or a piece has come off or something, we need time to fix those. So these need to be produced before. And then comes one of the most important things. Of course, everything is important, but the planned drawing date, because this means that the drawings for these elements have to be completely 100% finished before latest at this date. So let's say that -10 working days as well for the planned production date that we had before. So that we say, I know that this is probably not like the real world, where it often is that we have a production make sheet or a production drawing finished 2 minutes before we cast it. But in this ideal world, we want it to be finished 2 working weeks before. So we have time to plan everything nice and easy. So now everything is ready here. Everything is done, the rough planning is done here. So I have the drawing dates. That means that all of my designers can see this specific element here has a planned drawing date of the 21st of May, which is right around our next webinar actually. So they will be able to see, well, if I'm responsible for these sandwich panels, I know exactly when I need to finish my drawings, which is of course a very nice thing to know. Let's say that we actually finished the drawings for all elements. What we'll do is then we will say that all of these elements, let's take the whole building. Can I do like this? Control all. And we actually want to set all the elements to ready for production. So set ready for production here. save these changes, and so we can see we have the same thing here. Then I can change the element color to ready for production. Now they're green. So the webinar is actually almost finished now, but before finishing it off, I actually want, as I said, I have multiple floors in this building, so I want to copy these elements up for the next building so I can keep working on them there. But I know that they'll be very, very similar to the ones that I have here. So what I'm doing is I'm picking the whole floor here, first floor, and copying elements and element marks, increasing the number with 1000. That was why I gave the number 1001 before. And even for the ones that have shop drawings, I like it to copy those as well, just so I don't need to click the button twice. So there we go, pressing OK here, and it will copy up the whole floor, which doesn't take many seconds. So, and now you can even see, well, the green elements are ready for production. And it will also be the green elements that we'll do a full 3D detail planning, cast planning of on the next webinar. Well, thank you all for attending this webinar, and hopefully we'll see you soon at another webinar. Bye-bye, and have a nice day, everyone.